So guys, I'm going over exam 3 practice problems that I posted on Canvas. And I'm like, why not? I was going to make an answer key anyways, but why not record this and kind of talk through this in case you want to have that review video. I know you guys are working on Alex because like I told you, even if you're taking the paper pencil version on this of this exam, it will be similar. And I really got these from Alex. But I know sometimes we feel more comfortable doing math on paper, right? So that's why I have that option available for you. I'm going to go ahead and go over this practice problems and probably going to divide it into a couple separate videos because I have so far 21 problems. Let me go over maybe the first 5 in this video, and then I will come back and go over the rest of them with you, okay? So I put all these solving equation parts first part of this exam. So when you are solving, and I got your 3.5 daily problems, they were looking great. We're going to show work, we're going to find the exact value and also the approximate solution. So let's start with number 1. We're going to go ahead and solve for x, which is stuck up there. Let's add 2 to both sides. Whoopsie, that's a little too big. Add 2 to both sides. Then you have 3 times e to the 5x plus 1 equals 15. Now divide both sides by 3. E raised to the 5x plus 1 equals 5. You've seen this problem, didn't you? Yes, this was the daily problem. This was a 3.5 problem. And the step number 1 and 2 was just isolating this exponential term. Now, this is when we're going to take natural log of both sides. If you take natural log of both sides, you're going to get this. Notice what happened to this natural log of e. That cancels out, or that just turns into 1. But before that turns into 1, we can bring down that power of 5x plus 1 and then have it in that form. Subtract 1 from both sides, you get 5x equals natural log of 5. Let me draw a parenthesis over here. Divide by 5, here's your final answer. The exact value is going to be x equals natural log of 5 minus 1 divided by 5. Carefully type this into your calculator. Natural log of 5 minus 1 divided by 5 is 0.1219. I'm just going to round it to the nearest, 4 decimal places. So I wanted to... This was actually an exam problem last semester, but I did give this to you as a 3.5 daily problem. Let's go over a couple more. Now, some of you are solving this in a very bizarre way. Where is that coming from, really? Where'd you get that? I don't say anything, but when you did something little... honestly, when you showed work that looked like it was from some kind of online calculator, I told you to just do it again. Take natural log of both sides here, please. Take natural log of both sides, or take log of both sides, either way. But some submissions that I got last week, and they were identical. Some of you were turning in work that look exactly the same, step by step, but a method that wasn't very efficient. That method that was taking you... so when you're taking this on the exam, if you're doing the paper pencil exam, if you're showing me the work, please either take natural log of both sides, okay? Instead of typing this into some kind of online calculator. Okay, so let's take natural log of both sides. Natural log of 5 raised to the 2 minus 5x power equals natural log of 2 raised to the 2x plus first power. Now these exponents, these powers will come down, right? I'll have 2 minus 5x times natural log of 5 equals 2x plus 1 times natural log of 2. And then you have to distribute these natural log in. Then I'm going to have 2 natural log of 5 minus 5x natural log of 5 equals 2x natural log of 2 plus natural log of 2. All right. What you're going to do is search for all the terms that has x in it. This one has x in it. This one has x in it. I'm going to put them in the same side. And to be honest, I do want to keep them on the right side just because this one is a negative. So I'll do that. What I underlined in green, they don't have x in it. So I'll keep them to the left. I'll have 2 ln 5 minus ln 2 equals 2x natural log of 2 plus 5x natural log of 5. Okay? And then what? The left side just have to wait for a second because I'm going to now factor out these x's. Okay? I'm going to factor out the x and have 2 natural log of 2 plus 5 natural log of 5 left in there. Now we're done, right? We have to just divide both sides by that term. Let me go ahead and just minimize this a little bit smaller. Okay, so at that point, we're going to divide both sides by 2 natural log of 2 plus 5 natural log of 5. 2 natural log of 2 plus 5 natural log of 5. And that is the exact value. X equals, as you know, hold on. I mean, this term got canceled out right there. 2 natural log of 5 minus natural log of 2 divided by 2 natural log of 2 plus 5 natural log of 5 is the exact answer. And let's type this in carefully onto your scientific calculator. 2 natural log of 5 minus natural log of 2. And I'm typing this in my scientific calculator that I have. 2 plus 5 natural log of 5. So what did you get? You should get 0.2677 for the rounded answer, okay? So for the exponential equations, you do not really have to check the answers unless you really want to. But for log equations, I will ask you to check your solutions, and I will type that on your exam because log, we have the domain restriction. So number 3, we're going to look at that log equation. But when you're done solving for it, we will check for solution. We will see if it's an extraneous solution by plugging in. And very often I had to send back classwork and say, tell me, okay, I get that y x equals -3 is an extraneous solution, but why? Show me the work, why? And I had to do that because I don't think that online calculator really didn't give you that part. So let's go ahead and go over this one together. Solve the equation, make sure to check your solution. Now look, they have a log expression on both left and the right side. Here's the good thing though, they're both log base 7. So if they have the common log base, what you can do is you can just set these arguments equal to each other. Just grab that out and then just set it equal to each other. Let's solve this. Let me add x to both sides. I get 14 equals 3x plus 11. Subtract 11 from both sides. I get 3x equals 3. Therefore, x comes out to be 1. So what you will need to do is now check your solution. Because for log, if you plug it in and you get a negative argument, then that's not really a solution. So if you do log base 7, 14 minus 1, that turns into log base 7, 13. That one's checks. 13 is a positive number. That's good. If you get anything like 0 or negative, throw out that answer. That's when you have an extraneous solution. Why not? Let me plug it into the other side. If I plug it into the other side, I will get 2 plus 11. So I get log base 7, 13. And notice how the left side and the right side came out the same. But not only because I wanted to see that, left and the right side coming out to be the same, but because I wanted to see if both of these arguments stay as a positive number. Because if an argument comes out to be negative, that's when you're going to say, oh, this is not a solution. This is an extraneous solution. So this one, I ask you to check your solution. It did come out to be a solution. So x equals 1 is correct. All right, let me do 2 more. Number 4 and 5, and then I will stop and go over the word problems here. All right, solving equation. Solve the equation, write the solution set with exact values, and give approximate solution to 4 decimal places. All right, let's take a look. I need to first isolate this log expression, right? So subtract 4 from both sides. 3 times natural log of x plus 2 equals 15. Now what? Divide both sides by 3. You get natural log of x plus 2 equals 5. Now we're going to rewrite this in exponential form. This is where you're going to have to rewrite in exponential form. So let's do that. What's the base? What is the base of natural log? It's going to be e. E to the 5th power equals what? X plus 2. So if you're solving for x, subtract 2 from both sides, we have our answer. X equals e to the 5th power minus 2. So for the exact answer, give me e to the 5th power minus 2. That is not rounded. This is what I mean by exact value. Now, after that, type that into your calculator. What is e to the 5th power minus 2? That is approximately 146.4132. So, round to 4 decimal places for me on this exam. And this, well, now take a look though. This is technically a log equation, right? So I didn't write it, but what should we do? We should check the answer, right? So check the answer by plugging this into the equation. And really, I'm just going to plug in this number into the argument. Natural log of 146.4132 plus 2. Well, that's going to be natural log of 8.4132. This is positive, right? So what does that mean? So this is okay. So if you get an x value, a solution that makes your argument negative, that's when you have to say, oh, this solution is no good. This is extraneous. But for these log equations, at least just, and on the exam, if you're showing me the work on the paper pencil exam, do show me that you're checking this, because I will ask you to show me. I will ask you to check your solutions, and if I'm missing that part on your exam, I will take some points off, okay? Not much, but a little bit. And if you miss, if you make a mistake and say that an extraneous solution is a solution, then there we lose some points there. All right, last one on this video, and I'll be back with some more word problems and some other types soon. All right, number 5, solve the equation. Write the solution to the exact value given in terms of common or natural log. Also give approximate solution to 4 decimal places. Now they said common or natural log. Guess what I'm going to go with? I'm going to go with common log this time. Why? Look at the base. Base is 10. If the base is 10, the answer just looks nicer with common log because common log has base 10. If the base is e, then I suggest taking natural log. But it's not wrong if you do the other way around. It's okay. It's okay. It will just not be as simple. But let's first go ahead and simplify this equation so that we have 10 to the x plus first power equals 3. And then we're ready to rewrite this in. Rewrite this in what form? Log form. Okay? So, log base what? 10, right? Of 3 equals x plus 1. Now, what is log base 10 though? What is log base 10? That is just common log. So you can write that as log 3. If it's base 10, you can skip the base. So if I subtract 1 from both sides, I get x equals log 3 minus 1. And the reason I put 3 in a parenthesis is because I didn't want somebody to be confused and subtract 3 minus 1 here. So the exact value will be log 3 minus 1. The answer, if I type this into the calculator, the decimal is going to be log 3 minus 1. It should come out to be negative 0.5229, okay? So, when you are getting an answer to an exponential equation, you really don't have to plug it in and check it unless you want to see if the left side really equals the right side. But I will ask you to, and I will type it on the exam for you, all these. I should probably type this in here. I will ask you to check your solutions for every logarithmic equation problems, okay? So that was just a review of 5 problems that we solved, types of problems that we solved in section 3.5. But there are more fun problems that we're going to go over. I have 16 through 21 left. I will post them as I record them. I will also post the answer key to this. But this is really, I copied and pasted the practice, one version of the practice test on Alex over here. So expect to get something very similar, even if you're taking the paper pencil test, okay? See you soon.